Kinematic equations for uniformly accelerated motion. Kinematic equations. At the outset, I will be discussing for uniformly accelerated motion. If the change in velocity of an object in unit time is constant, then the object is said to be moving with a constant acceleration. And that motion is called uniformly accelerated motion. Let me repeat once again. The change of velocity, take down the change in velocity, that is delta V, of an of an object in each unit of time. Each unit of time. Then this object is said to be moving with constant acceleration. Constant acceleration. And such motion is called uniformly accelerated motion. So, do you understand this term, Prisha? Are you able to understand this sentence? Yes, sir. Can you explain on this? So it basically means that when there is a change in velocity, which means that either direction is changing or the length of the path is increasing. The change in velocity with time is constant. Means that there is like equal change in velocity in equal intervals of time. So delta V in each unit of t, and that is said to be having constant acceleration, and that motion is called uniformly accelerated motion. Right? Now, let me consider an object moving along a straight line. Okay, it moves along the straight line. Okay, with a constant acceleration. With a constant acceleration. So constant acceleration A. So this constant acceleration is represented as A. Now U be the initial velocity. Let me start from here. And this is the initial velocity. Let me say this is P. Let me draw a diagram so that you can easily understand. And this is the time axis T, and this is the velocity. This is the velocity. Y-axis is the velocity. So initially it is u, and it after certain time, that is it is v, final velocity. So here, and this is the point P. So this is O. Now the object P to Q it moves, right? And draw a vertical line to the x-axis. Then you draw another parallel line to the x-axis, and now you know that is this is R, this is D,
Of course, this takes place in t seconds, so you can mention this as t. And here, the difference here is change in velocity, that is v minus u. So, what is acceleration? Acceleration is change in velocity divided by time. But this change, that is this a, is maintained, okay, as constant. So in this case, the initial velocity at t is equal to 0 is called u. So what is u? It is the initial velocity when when t is equal to 0, right? What about v? That is the final velocity, okay, at t. That is when the object moves after t time. So after t. So t is the interval, that time period after t. Now let us discuss about the velocity time relation. So here the A is called the slope PQ. Which is the slope? This is the slope PQ, because A is equal to the difference in y-axis divided by the difference in x-axis. What is the difference in y-axis? This is VU, this is V. It means that is this part is U, okay, and this part is, and it has reached V, okay. Now V minus U, sorry, that is dy by dx. So dy is nothing but here QR, that is this portion, QR, okay. So QR divided by PR, right? That is dy by dx, PR, okay, which is nothing but the slope, right? Because it is dy by dx. dy by dx is called the slope. It is represented as m here, right? Proceed with next. Next. Therefore, A is equal to QR by, so which is nothing but the slope. And from the graph, we can obtain the acceleration just by finding out the slope, that is PQ. And it means there is a relationship between V minus U divided by T, that is nothing but A. It means V minus U is equal to AT. Therefore, V is equal to U plus AT. So this is the first kinematic equation. It is nothing but the relationship between V and N, right? Now let us proceed with the position time relation. Position time. And here, what is displacement? Displacement usually it is the object of an it is the object of in a given time how it travels. So displacement of an object is the interval, in the interval how much it has moved. So it is represented as x. Therefore, the displacement x is nothing but the area of what? Now look at this diagram. This is nothing but the area enveloped, that is the area under the slope PQ. So what is the area under the slope PQ? the area of a triangle plus the area of a rectangle. Do you understand this point? Okay. So what is the, can you identify the triangle? What is the triangle? PQ. So what is the area of a triangle?
Half into base into
Half into base into. So you can take this as a half into QR into PR, right? Take down. So the area of a triangle, area of triangle PQR plus, and what is the next one? Area of what? The rectangle. What is that rectangle? Can you identify the rectangle here? OTRP, OPRT. Okay. So OPRT. That is the rectangle. So rectangle OPRT. Right? Therefore, half BH means half into QR into PR. Close the bracket. Plus, tell me, what is the area of OPRT?
length into breadth, which is yeah,
That is OP into PR, right? Length into breadth, OP into PR. That's good. Okay. Now, half into, what is this QR here? QR, which is nothing but V minus U. Got it? Okay. So you can put V minus U instead of QR, right? And what is PR? Can you tell me what is PR? PR.
PR is T.
Very good. That is the time taken. So T, right? And plus. Now you already know what is OP, OP, U. Is it no?
U.
And what is C or here once again? C.
T. Is T.
T. Okay. Therefore, X is equal to V minus U whole divided by, in fact, Vt plus minus Ut divided by 2 plus, what about this? Ut, right? Got it? Okay. So it means V minus U divided by, in this case, that is, what is V minus U? We already know. You need not do this because you can replace this by V minus U is equal to AT. So we can replace this by AT simply, right? Into this T and plus ut. So it means x is equal to ut plus half at square. Okay. Sometimes this x is also represented as s. Therefore, s is equal to ut plus half at square. So this is the second kinematic equation. So what is this relation? Position time relation. What do you call it? Position time relation. Now let us move to, yes,
Can you just go back to that figure once? Figure. So in the
this is,
first, so the P point is the initial velocity, right?
tell me,
Point P, where the P is, that is the initial velocity, right? That is U.
no, 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 0 to P, that is the, that is U,
Okay, so first move from 0 to P and then P to Q.
yes,
So,
and this distance is V minus U.
okay, okay, got it.
Then, here, let us move to the next one, that is position velocity relationship, that is the third one, take down. position relation, position velocity relation. What is that? Position velocity relation. Again, the displacement in the time interval. The displacement in the time interval t is given as x. So what is this? Which is nothing but x. And this is the area of what? The area below the slope. So this is a kind of a OPRT trapezium, right? So this is the area of trapezium. That is, what is that? OPQT, right? So you can call it OPQT. And this OPQT consists of one triangle and then one rectangle. Okay, right? So we can proceed the same strategy 1 by 2, and here that is half into, okay, half into, this is OP plus QT into, that is OT. What is this OP?
PU.
OP is U. And what is this QT?
QT is V minus U plus U.
So we can straight away put U plus V, right? So that is nothing but that is U plus V into what is this OT? T, right? Therefore, half into, and then you got this U plus V into T. Okay, we already know that is V minus U is equal to what? V minus U divided by A is equal to T, or the original equation is V is equal to U plus AT. From this I have derived. So I can replace the time here. Okay. So let us replace the time. Therefore, U plus V into, instead of T, I can put this V minus U divided by A. We know A plus B into A minus B. What is that? A square
A square minus
B square. Therefore, here also 1 by 2A into, this is X. V minus U into V plus U means that is V squared minus U squared. Correct? Okay. So you can bring this 2AX here, that is equal to V squared minus U squared. Therefore, V squared minus U squared is equal to 2AX. Okay. So this is the third relation. What is that relation? Position and velocity relation, right? And we can derive the displacement of the particle in the nth second also. Let us do it, right? And this is also called, instead of x, they may put s also. So in that case, v squared minus u squared is equal to 2as. So these are the most, popular kinematic equation. So what of that? Tell me, what is the equation number one? V is equal to u plus a. Second equation, S is equal to ut half a t squared. And third, tell me, v squared minus u squared. So never forget this. Okay. Now let us move to the fourth one, displacement of the particle in nth second. So we are interested to determine the displacement of the particle in the nth second. Okay, now listen. See, that is an object is moving with some initial velocity, say u, under constant acceleration, that is a. Now, the displacement has occurred. For example, from O to it goes like this here. So, in nth second, what could be the velocity? So, in order to calculate this one, you can. So, the display, not display, displacement of the particle in the nth second. So it goes, we would like to find out the displacement of the particle in the nth second. Suppose, for instance, that is a displacement. Let us consider displacement of the particle in nth second. Okay, so this means you got the n, Sn minus Sn minus 1. Do you understand? In AP, you would have studied like this 0 to 1, 2, 3, 4, 5, 6. Suppose if you have got n number of particles or n number of positions, what is the previous position? That is n minus 1. What is the previous position? That is n minus 2. Do you understand this? Okay.
Yes, sir.
So we are calculating this distance. Are you able to follow? Sn minus Sn minus 1. It means a final minus, this is called ultimate. Sn is ultimate. N minus 1 means penultimate. Okay. You should note down this term. This is called ultimate. Ultimate means final. Penultimate means one step before that. Penultimate. Take down. So the displacement in nth second means what is the difference in position between the ultimate and penultimate position. Are you able to understand this? So the ultimate position is represented here as Sn. Penultimate is Sn minus 1. Got this? So we have S nth. Okay. What is that? S nth is given by, take down, that is U n. Instead of ut, you can put U n, right? Plus half at squared. Instead of a t, you can put half a n, right? Square. Got it? We have got already that formula, that is x is equal to ut plus half at squared. Instead of t, you can put tn. Instead of tn, you can put simply n, right?
Yes, sir.
Okay. Some teachers, they teach like this. Sn is equal to u into, they put tn. They maintain the same t. Okay, but in your book they are adopting this representation. So both are same only. Okay, right? Is it clear? So instead of Tn, they have put n, and here n squared. Okay, close it. And then instead of t, you have to put n minus 1. Do you understand? So here, yes, n minus 1 means what? That is u into t n minus 1 plus half into a t n minus 1 squared. So instead of t n minus 1, I am putting simply n minus 1. Got this? So that it will be easy for you to understand. And therefore, u into n minus 1 plus half into a into n minus 1 the whole square. Close the bracket. Right? Therefore, is equal to, now you have un and half an squared, right? And then you can multiply this u into n un and minus into un minus un, right? u into minus 1 minus u. Minus u into minus plus u, right? And minus into plus minus. Is it not? So minus 1 by 2 a into, you can put n minus 1 the whole square. Okay. So I expanded this bracket. Now what you can do, that is you have got this a n square, is it not? And another half into a n minus 1. So in that case, you can take out, and un is cancelled here, right? Therefore, you are left with only u. So u minus, okay? Instead of minus, you can put plus. So half a is common. So a by 2 is common. So open the bracket. It means n square, right? Minus n minus 1 the whole square. Got it? Okay. Are you following correctly? Now you can expand this u plus a by 2 into n squared minus, what is that? A minus b whole square. That is a squared plus b squared minus 2ab. So here n squared, that is minus n squared, and then plus minus 2n. So minus of minus plus 2n. Then minus, I mean plus 1. Plus into minus, minus. So minus 1 whole square. Got it? So it means you can strike out this. Now the result is, that is S nth displacement is equal to U plus A by 2 into 2n minus 1. Okay. So this is another formula that can be taken as the fourth relation. Okay. Got it? So let me summarize. We have V is equal to U plus 80. S is equal to U plus half 80 squared. V squared minus U squared is equal to 2AS. S nth displacement is equal to U plus A by 2 into 2n minus 1. What is this n? That is nothing but Tn. That is that nth T, nth time. Okay. Got this?
Yes, yes.
Now let us discuss some problems based on these equations. Okay. Take down. A motor car starts from rests. A motor car starts from rests. What do you mean by that? U is equal to 0. Starts from rest. And uniformly, accelerates uniformly for 10 seconds. For 10 seconds to a velocity 20 meter per second. So they are not given the acceleration value. Simply the car is accelerated. After that, car runs at constant speed, constant speed, and finally brought to rest. It means V is equal to 0, right? When it is brought to rest means what? V is equal to 0. In 40 meter, at that time, the distance is 40 meter. Yes, with a constant acceleration. So the acceleration is constant. There. The total distance covered. So the total distance covered is equal to 640 meter. Find the value of acceleration retardation. Retardation means what? When the car is brought to rest means retardation, negative acceleration. That is retardation, minus e. And what is the total time taken? So what is the total time taken? So these are the questions. Now let us try to visualize this problem. In physics, you must always visualize the problem so that it will be easy for you to include the appropriate concept in solving the problem. Listen, the car starts from rest and it moves. Okay, the car starts from rest, then it moves, and then so this is the x1 position. And suddenly, I mean, after that, after moving certain distance, it is brought to rest. It means x1, x2, x3 positions, right? You understand? Now, what is the first instance? What is the time taken initially? So in this case, u is equal to 0, right? Because it starts from rest. And in how many seconds it has gone to the second position, that is t is equal to 10 seconds, right? At that time, what was the velocity at x2? The velocity was, that is v is equal to final velocity 20 meter per second. So do you understand? Now, what is left here? Can you identify? The acceleration is asked. You got u, t, v. So you can apply v is equal to u plus at formula, right? Okay. So likewise, you must be able to select the appropriate formula. So v is equal to u plus at. So v in this case 20, u is equal to 0, a is to be found out, t is equal to 10 seconds, right? It means that is 10a is equal to 20, a is equal to 20 by 10, that is 2 meter per second square. So now we have found out what the acceleration. Are you comfortable?
Yes.
Now let us proceed with, we had to find out the x1 position, is it not? So x1 position, what is the position and what are the four types of relations we discussed? The first one is what? That is, what is this one? What is the first one? What is the first one we discussed? What is the relationship here?
Primary.
Yeah. So in that case, we discuss about the position and time. And second, not position. The first one is velocity time. So I have mentioned, I have not mentioned it is. So you can put velocity time relation. So this is the first one. What is the second one? Position time, which is nothing but S is equal to ut plus operator square. Third one is position velocity relation, okay, which is nothing but v squared minus u squared is equal to 2s. Third one. Fourth one is the displacement in the nth second. Okay, so we have to use the appropriate relation here, right? Now in this case, here v is given, u is given, t is given. You are supposed to find out a. So we can make use of this velocity time relation. That is nothing but v is equal to u plus at. Are you able to follow? Right. Next one. Now we are supposed to find out the displacement. So in that case, we have to move up to the next one. That is displacement. Okay. So we have to find out the position time. Position time relation is nothing but s is equal to ut plus operator square. So we can use that one. Here, S is represented as x1. That is the first instance, is it not? So x1 is equal to, what is the formula? We know the formula. S is equal to ut plus half LT square. Let us apply the same formula here. Therefore, x1, instead of S, you can put S1. X1 is equal to, and here ut, what is u here? 0. So 0 into t, right? And then plus half into, what is the value of a here? 2
2,
into, what is the time taken? T, 10 seconds.
10 seconds.
10 square. So here also 10. This is 10 square. So this becomes a 0. Therefore, x1 is equal to 2 cancelled. So 100 meter, right? Okay. This is the first part. And the second part of the motion, this is the first part of the motion. Now we have to calculate what the second part of the motion. Okay, right. So for the second, so note down this, for second part of the motion, of the motion. So for the second part of the motion, we can proceed like this. That is, now let us state, that is x1 is already taken as 100. Is it not? And what about here? The S is 40 meter they are given, which is nothing but x3. Is it not? X3. So this is x1 and this is x3. So we have, and we are supposed to find out x1 to x3, right? Okay. So it means, and now we want to find out the in between, that is overall. This is x2. So the overall distance x2 is nothing but this x1. X1 means this is x1 and this part is x3. So we are finding out x2. So x2 is nothing but x1 plus x3. So what is x2? X1 is, this displacement is 100 plus, what about this? This is 40. Is it not? That is given here. Therefore 140 meter, right? Okay. So we have found out now, that is 140. Okay. So we have x1 and I'm sorry, we have x2. Yeah, what is x2? What is x2? X2 is given here. X2 is not, this is not x2, x3 is given. So x3 is given. How much? 40, right? But the overall distance, they are already given as how much? The total distance is 140. But we do not know. That is put together is equal to what? 640. It means, now let me redraw the diagram. So this is x1, x2 and x3. So x1, x2, x3. So we know the position of this one and position of this one. So this is in the 40 meter. This is in the 100th meter. So if it starts from here, what is the total? Means S is equal to x1 plus x2 plus x3. So here S is already given. The total distance is how much? 640. 640. And the x1 is how much? X1. That is, it starts from 100. We do not know this. How much? 100. And what about this distance? This is, say, about x2. We need to find out. And x3 is 40. Is it not? 40. So it means 640 and minus 140 is equal to x2, that is equal to 500 meter. Okay. Do you follow this? So now the X2 part is 500 meter. So the distance covered by uniform speed of 20 meter is 500 meter. Yeah, tell me.
So, x1 to x2 is 100, x2 to x3 is 40,
X3?
40
No,
meters
no,
is
no, no, no. That is, this is not 40. Actually, it is when it is coming here. Now listen to me. When it is coming here, when the car is coming here, suddenly a brake is applied and it stops in 40 meter. Do you understand this point? This is not the actual distance between this. Okay. Now listen to me. Let me explain once again. The car, this is the road. The car is moving like this. Okay. Now it starts from rest. Now it is moving at certain speed and it reaches here. Okay. And after that, once again, it picks up the speed and the constant velocity, a constant acceleration. Then, and when it, before reaching here, all of a sudden there was an obstacle here. At that point, okay, at that point, they apply the brake, immediately it comes to rest. Do you understand this? So when it comes to rest in how many seconds it is given as comes to rest in what is given here? Yeah, comes the constant speed. It is brought to rest means v is equal to 0, and at that time it takes a 40 meter. So when you apply the brake, you cannot expect the car instantly stop at the point. Do you understand? For example, the car is moving. I apply the brake. After application of brake, also it moves a little bit, and that distance is 40 meter. Do you understand this? Okay. But still we do not know. We know this distance, that is x3. We know this distance, that is x1. But we do not know this distance. Are you able to follow? Okay.
Oh,
Now, indirectly they have given the total distance is how much? 640 meter. So now we already calculated x1 as how much? 100, and x3 is already given how much? 40, right? Now based on that, we can find out x2, which is 500. Are you able to follow? That is this one. Okay,
good. Got it.
right. Now see, that is we have completed this distance part of it very clearly. Okay, now the time taken, what is the acceleration here? Uniform acceleration, right? What was that?
So we have to find out the retardation over here.
What is I mean, that is,
So
what do you
we
mean
can
by time taken, not this one? That is, what is the total time?
Hmm.
We had to find out. Okay. So here we know the formula. Listen, see, what do you mean by velocity? What is velocity? Displacement divided by time. Now we need to find out time. So time is equal to displacement, that is S divided by V, right? So using the velocity and the displacement, we can find out the time. Now what is the total? Now we are going to find out the time. T is equal to, what is that? S, that is displacement. And how much, what was the distance? No, the distance covered with uniform speed. Okay. And in that case, that x2, because now listen to me, I'll show you the diagram once again. So from here to here, it is 100. From here, okay, listen to me, from here, when the car is traveling, At what speed? 20 meter per second, right? At what speed? 20 meter per second. From here, it was brought to rest, and it have, I mean, brought to rest means when they apply the brake, and even after applying the brake, it moves to another 40. Do you understand the statement?
Yes.
You cannot expect the car and even your ceiling fan, when it is switched off or when it is applied brake, instantly, immediately stop at that point. Okay, it moves a certain distance, then it takes rest, right? And that distance is 40. And before that, how long it has been traveling? Only 500, right? Because x2 is 500. Got this point? This is what they have asked. Okay, so what is the question? Let me read once again. You please go through the question. Can you read the question? Have you noted down the question?
With motor car initially traveling there.
Motor car starts from rest and accelerates uniformly for 10 seconds to a velocity of 20 meter per second. After the car runs at a constant speed and it finally brought to rest in 40 meter with a constant acceleration. So the total distance covered is 640. Find the value of acceleration, retardation, and total time. Okay. Now our objective is to find out the retardation. Are you able to follow? We have to find out the retardation. So for which, what was the speed in the second phase? So that is very important to us. And that is why we consider that distance as, now the second part of the distance is 520. So you have to consider this distance. You cannot take the entire distance. Do you understand this point? Right?
He won't even add 40.
They are specifically asked what is retardation means. You have to consider only the next speed. Okay. So here T is equal to, what is S? 500, which is nothing but the X3, correct? Divided by, what is that V? The V is nothing but 20 here. Okay. So divided by 20. Now it becomes 25 seconds. So that time taken is 25 seconds. So because that time is very, very essential here. Okay. Now this is the second part. Correct? So the first part is this one. We have already calculated the previous one here. Now the second part. Now let us move to the third part of the motion. Third part of the motion. Okay. So now are you able to understand? From this to this, listen to me carefully. From this position to this position, first part. Okay. From this to this, what is that? Second part. And from this to this, third part. Do you understand? So draw this diagram. Are you able
Yes.
to? So this is x1, this is x2, this is x3, right? From where it is gone. Okay. Now you can put x3 here safely because it is in between position. Now, um, so let us consider the last part. Here, for the third part of the motion, u is equal to what? 20 meter per second. Because that was the running velocity, is it not? And the car was stopped, means it brought to rest. When it's brought to rest, means v is equal to 0 ms power minus 1, right? Got it?
Yes, sir.
Now, what is the x here? X is nothing but that x3, which is nothing but 40 meter, right? Okay? Because when the brake is applied, it has moved to 40 meter and brought to rest. So that displacement is 40 meter. Now using this, now we can apply v squared minus u squared is equal to 2as formula. So in this case, x3, okay? Therefore, what is v? 0, v squared. Then u squared, 20 squared is equal to 2 into what is the a? We have to find out what is s, which is nothing but x3, that is 40, right? So this is, now listen to me, don't mistake that minus 20 the whole square is different from minus 20 square. Do you understand this? Prisha, can you explain?
So minus 20 whole plus 400, which is
Plus
minus
4,
20.
but here it is
20 squared is
minus 400. Okay, so you have to be very careful. These are all the misconceptions. So sometimes during the examination time, out of a hurry, that is, we will forget. We will immediately put a minus 20 whole square is equal to plus 400. So be careful. So this is minus 400 only is equal to, and what about this? 2 into 40. So you can bring this here. Okay, is equal to A. Now what is the answer?
minus a is equal to 5 meter per second.
So that is equal to minus 5 meter per second squared. Okay. And that is why we call this as a retardation. I hope now you should be able to understand this. Right? So minus A is equal to, you have to put like this. Minus A means retardation. 5 meter. You can make this as plus. Okay. So this is the final answer. Now let me summarize all these answers. What was the first question they are asked? Let me go back. What was the acceleration? A. So A is equal to what? How much?
2 meter per second squared.
Very good. 2 meter per second squared. And what was the next one? Retardation minus A,
5 meter
5
per
meter per second squared. Okay. And what was the, now we had to calculate the total time. We had to calculate the total time. Shall you calculate? Now listen to me very carefully. So here, once again, we had to do some gimmicks here. Now we have to find out, that is the time taken for retardation. Okay, when you apply brake, it has moved to certain distance, and we are calculate the what the retardation, but we do not know how many seconds it took to stop the vehicle. So we had to calculate that one during the retardation. Do you understand? So we need to find out the last time taken for retardation. Take down the last part is equal to, what is that? That is T is equal to V minus U divided by A. This is the formula. Where from I got it? That is from the velocity position, velocity time graph. Is it? Yes. So that is equal to, so here, what is V? 0, right? What is U? It was traveling in 20 meter per second. And what was the A? Minus 5. That is the retardation, right? You have to put minus 5. Okay. Got it?
second.
So it means now minus 20 divided by minus 5, that is 4 seconds. Now the retardation time, that is when the brake is applied, okay, in how many seconds the car was stopped? In 4 seconds, 1, 2, 3, 4. Now it is stopped. And by the time it has moved to 40 meter. I hope now you should be able to understand. Now car is moving at a 20 meter. Listen to me. Car is moving at a 20 meter per second. Now, there was one guy, all of a sudden, he crossed. Immediately, the driver stopped, applied a brake. Will it stand at that point? No, it will slightly move for how many meter? 40 meter, then brought to rest. And for which, in order to bring to rest, how many seconds it has taken? 4 seconds. And that is the very braking time. Okay, brake applied time. Now we can sum up everything. They have asked the total time because they have asked this question, total time. So the total time is, what was the first time?
10 seconds.
10 second. And what was the next T2?
25
25.
minutes.
And what was the T3? 4 seconds. Now we have to add everything. So it is 39 seconds. Okay. So the total time is equal to 39 seconds. Now let us sum up all these answers. What were the answers? What is A? Now these were the questions. A minus A and total. So total time. So what is acceleration? Acceleration is equal to how much? 2 meter per second square. And what is minus A? That is a 5 meter per second square. And what, so you have to present the answer in such a way. So total time T is equal to how much? 39 seconds. So this is the set of answer you have to explain. Right? Got it? Now, uh, let me go ahead with the calculus method. What's the time now? 7:30. Okay. Right. I will continue tomorrow. Okay. So tomorrow I'll be explaining about the calculus method of deriving these kinematic equations, and we'll be discussing about non-uniformly accelerated motion using integration. Then we'll be discussing about the equation of motions under the influence of gravity and what is weightlessness. So all these concepts will be discussed tomorrow. So by tomorrow we are completing this exercise, and meanwhile you please go through the uh, questions I already given. And today I'll try to share the solution. You please go through the solution first of all. For all numerical problems, you have simply cut and paste and sent it. You must try something at least. Just by looking at the problem, you should not be afraid of it. You must attempt. Anyway, I'll send the solution for that, and please go through the solution. And if you are unable to, that is, understand the solution, then you can ask me. Okay?
Okay, so thank you.
Right. So you can now check out, but keep working. Pardon?
So